Hey everyone, my name is Santiago Salas, and I'll be going over a few key ideas presented in my paper, which is titled A Focus on IAM Deprovisioning. So let's start with defining what IAM is. IAM stands for Identity and Access Management. IAM is also a framework used to control access to resources. The reason I'm showing two pictures here of Google Cloud Platform and AWS is because these are two leading cloud infrastructure providers. They also happen to make heavy use of IAM for admins to use to manage permissions. Now, these two cloud providers have also lowered the barrier of entry for organizations to get into migrating to the cloud or using the cloud to set up all of their services. So because they've made the barrier of entry so much lower, it's not necessarily a bad thing because now it's easier to get into it, but it also means the rate of adoption is increasing due to this. So if many more organizations are using these cloud providers, then it follows that they'll also be using IAM to manage access to all of their assets. So why is identity and access management so important? Well, for one, it provides a way to enforce authentication and authorization of users. It's also used for user management to add or remove users from a central user repository. Now, what this allows admins to do is they can control who can get into their infrastructure, and once they're in the infrastructure, they can also control what these members can access or what assets they're allowed to perform actions on. So they have this sort of permission matrix that they're in charge of maintaining. So sometimes these things are needed for compliance because the organization is required to limit access to certain resources based on the job requirements of the employee. For example, maybe someone in the legal department, it doesn't make sense for them to be able to stop or start production services. And aside from that, it's also in the organization's best interest because they want to protect their assets, right? They don't want just anyone from the general public to come in and see their secret sauce. So IAM becomes an important component for the security of the company as well. So for the use case that I'm going to specifically be looking at, it's when an employee leaves the company and returns. To sort of help visualize this, this is a small mock of an IAM hierarchy for a company called ABC. As we can see here, there's three members. There's Jack, Jill, and John. It can be seen that Jill sort of has some more elevated privileges. She's also the only one that can access a resource called network configs, and she has delete permissions for storage bucket alpha. So if we were to consider Jill leaving the company, there's usually two options that companies have on how to handle this. They can freeze Jill's account, which means the Jill at abc.co might get replaced with Jill Frozen, or they could also remove the account and all the bindings entirely, which means all those rows related to Jill get removed from the IAM hierarchy. Now, why would a company want to freeze an account? Well, the reason for that would be they can save the assets that are tied to that account. By freezing an account, they disallow people to log in, so Jill won't be able to log in to the account if it's frozen. And there's also the added benefit of them seeing what permissions Jill had. So if something goes wrong that Jill was working on, they can see what permissions are needed for someone else to pick up that job. But now what happens if Jill were to come back? So if Jill were to come back and the account was frozen and it gets unfrozen, now she might get all that access back, and maybe that's not appropriate. Maybe she shouldn't be able to see the network configurations right away. Maybe she needs to be onboarded correctly before she's given all this access back. Or in another scenario, what if Jill comes back and she's in a different role and now she's over provisioned? So this issue of lingering access that happens when you decide to freeze an account is something that I try to sort of address with my solution. And I have a demo that I'll be walking through later that'll sort of show how this IAM hierarchy table can change as these scenarios happen. But this table here is just to give you an idea of the base structure that I'm going to be assuming all my use cases and demonstrating my idea on. So very quickly, to sort of recap the motivating example, we'll be looking at what happens if Jill were to leave and her account is frozen. The bindings themselves don't get removed in that case. They just get bound to a frozen account. And the assumption there is that nobody can log into the account, so those permissions can never be executed. So what has been done so far? Much research has actually gone into developing IAM strategies and also analyzing existing ones for optimizations. The focus for the most part has been on how to grant permissions, which is why I'm writing my paper on deprovisioning instead of provisioning. I've referenced several other papers that other researchers have worked on in my paper and the related research section. For now, I'm only going to focus on one, which was titled DFOAF, Distributed Identity Management with Access Rights Delegation. So this paper tried to solve a scalability issue, and they tried to model their IAM infrastructure off of social networks. So there would be like two members, member A, who would be friends with member B, and that would be a direct relationship. And there may also be member C, who might be friends with member B, but not member A. So they went into detail about their distance calculations to see how far away or how several degrees of friendship one member was from another, and based on restrictions that that member placed on their resource, the other members that were maybe too far in the relationship graph might not be able to access it. So this paper went into much detail on how to provision members, how members would be entering this system. But one thing I noticed is that it didn't go into detail on how members would leave this system or how they would be treated if they were to leave and come back. For example, let's say member C stops being friends with member B, or in other words, they leave that system. When they come back, do they keep all their friendships, or do they need to start making new friends? And that's sort of what I've noticed in several other papers, that they go into a lot of detail on how to basically start up the access lifecycle, but they don't go into too much detail on the technical implementation on how to deprovision an account so that it aligns with their strategy. So my proposal was to add a way to archive permissions, and this would effectively have bindings exist in a separate structure, which I refer to as IAM escrow. What this allows us to do is to combine the benefits of account freezing and also the benefits of removing these permissions from the hierarchy so that they can't be acted upon if the employee were to return. So for my setup, it's pretty simple and straightforward. It was meant to just be a mock and just to go through this one use case. I used Python 3.7 to write everything. There was no extra packages needed to download. You just need Python 3.7. And I used a dictionary to create this mock IAM store, and it was used to store permission bindings. I created several methods that would manipulate this IAM dictionary, and I also wrote a script to walk through the use case. So now let's work through a use case and go through the different states that may happen from the scenario of Jill leaving the company. So this should look familiar. This was the exact same IAM hierarchy that I showed in the previous slide for a fake company called ABC. We see the same three members, Jack, Jill, and John, with Jill having a little more elevated access compared to the other two. So let's say Jill is leaving the company. She has some high-level permissions, so they decide to freeze her account. Now the IAM hierarchy would look like this. Instead of Jill at abc.co, we would see Jill_frozen at abc.co. But the key thing to note here is that the bindings are still there. The only thing is that now they're tied to an inactive account. So the idea here is that because this account is frozen and it can't be accessed, that these permissions could never be executed. Underneath the dictionary, you can see a couple of stats to quickly summarize the state that the IAM hierarchy is currently in. So let's say Jill comes back and her account is unfrozen. Now all these bindings that were there are tied to an active account that Jill has access to. So this may not be appropriate if Jill came back and she was in a different role, or even if she came back in the same role, it may still not necessarily be appropriate because she may need to go through onboarding before she gets all this access back right away. So the second option would be to remove her account instead of freezing. Then the IAM hierarchy would show only 2 members. And one thing that we need to take into account if we were to choose this route is that we lose that mapping that Jill may have had. So because she left with some high-level permissions, those bindings might be valuable to troubleshoot certain services that she was responsible for. So my proposal is, instead of freezing the account, we archive the bindings in a separate structure. This way we get to keep the history of the mappings, and we also get the benefit of those bindings not being stored in the IAM hierarchy, so that if she were to return, it would be as if she was a new employee and she would have to be provisioned from the ground up. So here you can see the IAM escrow in the lower half. So what this essentially is just another Python dictionary for this case, for like the proof of concept. But in practice, this would be a separate structure, and this would sort of just be a history or a snapshot of permissions. And this IAM escrow would store the bindings, and no permissions in this structure are executable, and they're not necessarily tied to actual accounts. It's just a snapshot so you can see what permissions were tied to an account, when it was archived, and we get to separate like history from executable permissions this way. So now let's say Jill rejoins the company. She must get re-added, but will have no permissions tied to her. If needed, like, we can look at the escrow to see what permissions she had and give back permissions based on that. But for the sake of this use case, let's say something happens and Jack needs to take over a service that Jill previously managed. So now the escrow can be used to review what access Jill had, and we assume Jack must gain all access that Jill had. So then we can merge in the permissions that Jill had at that time when we took the snapshot and provision Jack with those permissions so that he can complete the task. So the goal here was to introduce a deprovisioning method. IAM escrow should act as a supplement to a strategy that is already in place. It by itself is not really a strategy, it's just meant to help aid in the technical implementation of deprovisioning an account. So for this use case, we're assuming that the company wants to keep a history of the permissions mapped to an account, and IAM escrow is a way for them to help mitigate the risk of lingering access if they were to choose to just freeze an account. So this table just shows a quick summary of all the different IAM states that we were in when we walked through the use case example. So we see a couple here. We see the base state, which is where we started, the frozen member, when we removed the account, when we introduced IAM escrow, and also when permissions were merged from IAM escrow. So if we look at the legend, we see like the different colors corresponding to the different bars here, and they're either representing the number of active members or the number of resources or the number of frozen members in either of the structures. So if we focus on the frozen member, we see that there was 2 active members and 2 resources being bound to those active members, but there was also 1 frozen member that had 3 resources being bound to that frozen member. And that's not exactly what we wanted. We wanted something closer to the account removal state, where we only had actionable permissions on active members in the IAM hierarchy. However, we realized we lost the benefit of keeping that history of what permissions may have been bound to an employee that left. So when we look at IAM escrow, we see that we still only have the same permissions that we would have had in the account removal state in the actual IAM hierarchy, but in the separate IAM escrow structure, we have the permissions that were bound to the frozen member. So if we were to analyze this implementation, we could see that IAM escrow could be used to store access snapshots, which was the intended purpose. However, we also see that more granular control is needed to prevent over-provisioning. For example, when we walked through our demo, we saw that Jack gained all of Jill's permissions. However, maybe he did not need all of Jill's permissions to perform that task, so he might have been over-provisioned in that example. And so there may need to be another process put in place to help manage that. Another issue with this is that merging permissions is one way. And what I mean by this is that if we were to merge in those permissions from Jill's account into Jack's account, it may be tricky to figure out which permissions to remove from Jack's account if you want to bring him back to his original state. So one workaround for this may be to take a snapshot of Jack's account before the merge and then merge into permissions. He completes his task, and then we revert his access by observing the snapshot that we took right before we did that merge. Another thing to note is that we were sort of addressing a versioning issue with IAM Escrow, and there's another tool that sort of already addresses this that's pretty popular and well known called Terraform. So Terraform is a tool that provides like infrastructure versioning, but there is still a bit of a problem in dealing with frozen accounts, since when you freeze an account, the underlying identity changes for that account. So if you were to use Terraform to sort of try and accomplish the same functionality that IAM Escrow was doing here, you would need to delete the permissions before freezing the account, or else once you freeze the account, those bindings in Terraform will try to remove them from Jill at abc.co, not Jill_frozen at abc.co, which is what would be in the IAM hierarchy. But this is just something to note, and this is basically to serve as a critique of the implementation to show that this is still early and young and needs a little more development. So let's wrap this up with the future work. This was an initial dive into IAM deprovisioning, and different IAM strategies would have different use cases to consider. Some other use cases may call for different deprovisioning strategies. There's one called time-based access that was already implemented in some organizations that I've seen online, or I've seen blogs of them talking about it, where permission is bound with expiration time. So when that time hits, that permission is not executable anymore. Or something else that I thought would be similar and might also be useful would be a self-terminating process, sort of like the way limited backup codes work. So you get a permission and there's a usage counter, and when you run out of usages for that permission, you would have to restock, right? So this would only make sense for very high level permissions. So maybe if like someone is on call, maybe they have the authority to do some certain high level calls before running out and having to go back and restock. So IAM Escrow itself can definitely be further developed, and some more research would have to go into how this could actually be applied to a cloud infrastructure like Google Cloud Platform or Amazon Web Services. But this was, I felt, appropriate and showed what the proof of concept and what the workflow would be like in practice. If there's any questions you may have about this implementation, or you want an explanation onto why I did things a certain way, this is my contact information. Feel free to send me an email, and I'll try to respond to any of the prompts that I get. Thanks for watching my presentation.